two-proportion z-test. We're going to look at a hypothesis test dealing with two unknown proportions. The first proportion will be the proportion of people who are given $1 that spend their money, and the second proportion will be the proportion of those giving 4 quarters that spent their money. And so we're going to look at two samples of such groups. So in the first sample, we have 46 individuals and 12 of them spent their money. And in the other group, there are 43 subjects, and of those, 27 spent their money. So our hypothesis we're going to test to see if those that are given a larger denomination are less likely to spend their money than those that are giving smaller denominations. So we'll assume that the two proportions are equal, and we'll try to find evidence that the first proportion, those that are giving large denominations, that proportion will be less than the proportion of those that are given smaller denominations. So in a hypothesis test, we've stated our hypotheses. We're going to compute our test statistic and our p-value. So here I've illustrated how you might go through using the formulas to achieve the task of computing the test statistic and the p-value. What I would like to do here is show you StatCrunch. So if I press Stat and I go down to Proportion Statistics, we're doing a two-sample test. So I'll choose two samples, and here we're given summary data, so I'll choose the option Summary. So we'll just enter in the data. So from the first sample, we had 12 people that spent their money out of 46 total number of observations. And in the second, we have 27 out of 43. We're doing a hypothesis test. So we're assuming that P1 is equal to P2, in which the difference would be 0. And we're trying to argue that P1 is less than P2. So we change this here to less than. So if you just put the P2 on the other side, P1 would be less than P2. I'm going to go ahead and plot the p-value just to kind of show you what happens here. So if I hit compute, it'll run the test. And in this table, they've got the output from running the test. And so at the end here, they give you the z statistic, which is negative 3.49 if you round, same as what we have over here in the calculations. And it has a p-value of 0.0002. And that's exactly what we have here. I will say that in StatCrunch, it goes ahead and rounds things to 4 decimal places. So if it's really small, it could end up being 0.0001, just signifying it's less than that. And I noticed it's one of 2. Remember, I checked the box for plotting the p-value. So here it gives me the normal curve, and it plots z equal negative 3.49 over here to the left. And if you can see vaguely, it shades in that little bit of tail, which is kind of representing what's going on here in the picture that I've given down here for the p-value. And so in this case, we've got the test statistic and the p-value both given by StatCrunch. And so if the p-value is very small, typically less than 0.05, this is evidence that the proportion of those that spend the larger denominations is less than the proportion of those that will spend smaller denominations. So this is a two-proportion z-test.